Hello students, welcome you to this session. So in the last class we studied a lot of properties, right? So we studied associative property, commutative property, distributive property, then De Morgan's law, right? For two sets, that is for complementation, three sets for set difference. Then we did some questions for verification, okay? So today we are going to continue that. Now we start with this question. Look at this, a very simple question only. Using the adjacent Venn diagram, find the following sets. A Venn diagram is given. They put some numbers, right? So scattered all over the Venn diagram. Some elements are inside A, B, C, something outside and all, right? So can you say the elements in A? 4, minus 1, minus 2, 3, 6. Can you say the elements outside A, B, C? This 1 and 2, right? Can you say the term in A intersection B? So you must know what is A intersection B, right? This is A intersection B. What are the elements in A intersection B? Minus 1 and minus 2. Suppose I am asking what are the elements in A union B? A union B means you must know which portion. This is A union B, right? What are the elements there? 4, 6, 3, minus 1, minus 2, 5, 7, 8, right? Like that you can say. But only thing, you don't repeat the elements, okay? And better you try it if possible, write them in order, okay? So now let us see. So from the diagram they asked to find. First they asked to find A difference B. A minus B. What's the meaning of A minus B? In A, but not in B. So it should be in A. It should be here only. So 4, 6, 3, minus 1, minus 2, but not in B. So don't take these elements, okay? Don't take these elements. So only these three you should take. So what is your answer then? Your answer is 4, 6, 3. Write in order 3, 4, 6. Okay, so 3, 4, 6. So this is what? A difference B, A minus B. Okay, now next question you try. What they asked for the second one, B minus C. Not B minus A. Read the question very carefully. B minus C. That means in B, right? In B. This is B, right? In B, but not in C. Don't take C. In B, but not in C. That means you take only these three numbers. Which numbers? Minus 1, 5, 7. Okay, that three numbers alone you take. So now let's go for the next one. See the next one. A dash. What's the meaning of A dash? Outside A, right? A dash. Don't take A. A is outside fully you take. Then B dash. Don't take B. It's outside. You take the union of that two. So that means A is outside you take and B is outside also you take, right? And you take the union of that two. So can you say which terms will come? Only these two won't come. See, this will come, it won't come in A dash because A is outside, okay? So all the terms except this 5, except this 5, all the terms will come in A dash. But in B dash, see B, 5, 7, minus 1, minus 2, 8. Except these 5, all the terms will come. But in which this 4, 6, 3, 8, 7, 5, these will come in any one of the case, either in A dash or in B dash. But this minus 1 and minus 2 won't come in A dash, also it won't come in B dash. So when you take the union of that two, except that two elements, all other terms will come. So what's your answer? Don't write that minus 1 and minus 2, the term inside there too. Okay, that two leave it. All other terms you write. So if possible, you write in order. Okay, so even the outside numbers also you should write. Okay, so 0 is there. 1 is there, 2 is there, but before that minus 3 is there, right? So I'm starting with minus 3. Minus 3, 0, 1, 2, 3, 4, 5, 6, 7, right? 4, 5, 6, 7. Okay. So this is the answer for A dash union B dash. Now go through the next one. That also this complement only. A dash intersection B dash. Listen, A dash, A is outside fully you take. A is outside. Then B dash, B is outside. Okay. So can you guess, find out which portion will get? A is outside, so don't take this, okay? its outside portion fully you take. So everything will come, right? Then B dash means B's outside fully you take. B's outside fully you take. So in the intersection means common, right? So you will get only these numbers. Which numbers you will get? 0, if you want to write the negative term first. -3, 0, 1, 2. Okay, you can check that one. So A dash, if you want you can shade and check it, okay? Right, intersection means you take the common elements, right? So -3, 0, 1, 2 you'll get. Now see the next one. B union C the whole dash. B union C the whole dash. So that means outside B union C. So see what is B union C? Very easy one, right? B union C is this portion. B unions. For the question paper you should not draw anything like this, okay? But for the initial stage, for you to understand, I'm doing that. But by seeing that, you can leave that portion, right? This is B union C. If they ask B union C, these are the elements you have right, what I shaded. But here B union C, the whole dash, leave this, right? The remaining. What are the remaining? 1, 2, 4, 6. See the next one. A minus B union C. A minus means in the first set, not in the second one, right? A minus B union C means in A, it should be in A, but not in B union C. B union C, I already shaded, right? Don't take the elements that part, but it must be in A. So what are the elements? Can you tell me? In A, but not in B union C. In A, not shaded here. The numbers are what? Only 4 and 6. In A, but not in B union C. B union C already shaded there. Okay, don't take that. The remaining elements in A you take. See the next one. Next one, A minus B intersection C. So in A means all these things will come. This is A, in A, but not in B intersection C. B intersection C is this portion. Okay, leave that one. Remaining A you take. Remaining A means these elements you can take, right? In A, but not in B intersection C. Only these, what I marked here, that 4 numbers. Can you say the numbers in order? -1, 3, 4, 6. Right? Hope you understood all these things. Okay. So a diagram is given. From the diagram, how to take the elements. Now let's go for the next question. Look at this question. Verify distributive laws. 2 distributive laws I taught in the last class. You're remembering? One is intersection is distributive over union. Another one is union is distributive over intersection. Sometimes they specify, but here they asked distributive laws in plural form. So you have to write both and you have to verify. Okay, I'm going to explain one and the next I'm leaving it to you. So listen first, the 2 laws. The first you write both the laws. A intersection B union C equal to A intersection B union. Here union only. But demark allowed outside minus is there, no? When minus is there, you change. Union become intersection become union. But here nothing directly right. A intersection B, union, A intersection C. And the second one is union is distributive over intersection. So A union B intersection C is A union B intersection A union C. Okay, these are the 2 distributive laws. A, B, C, everything given in roster form. So very easily you can do that. Simple calculation. Among these 2, I'm going to teach you one question. Which one you want? Normally students will ask the second one, right? Because believing the last question may be tough. Nothing like that. Both easy only, right? Okay, anyhow, I'm going to give the proof of second. So first one I'm leaving it to you practice. Okay. So for the second one, first what do you need? B intersection C. So okay, now I'm going to rewrite all the sets. So K equal to A, B, D, E, F, right? Then L equal to B, C, D, G. And M equal to A, B, C, D, H. So one difference you have noticed. So it is not ABC. Instead of ABC, what they given here? KLM. So that ABC you convert it into KLM. Okay. So first we are going to verify to prove. So which one you are going to prove now? Second one. So second one means K union L intersection M instead of A, B, C. These are the laws. If A, B, C are given, you write like that. But here K, L, M. So we have to prove this one. K union L intersection M. Can you say the answer? K union L. K union L intersection K union M. That is why I said learn the positions you see. Don't try to mark up A union B equal to this now. Otherwise, once they change, instead of A, B, C, K, L, M, you will be confused what right. Okay. So K union L intersection M is K union L intersection K union M. Okay. Now let us do the left side first. For left side, first you find the term inside the bracket. L intersection M. L intersection M. Sometimes what happens, student by seeing this K, L, M and all, they will be a little bit uncomfortable because every time they like to do sums with A, B, C. Okay, so with any term, sometimes they give X, Y, Z, or M, N, whatever it is. Okay, the method is same only. Union, write everything, intersection, common. That's all. Okay, so L intersection M, you write the elements which are common for L and M. What are the elements common for L and M? B is common. C is common, D is common, right? So B, C, D. So now with that you take the union, K union L intersection M. So L intersection M, you got it. With that you attach this K also, union. So take that also, right? Without repetition, you write. So here A is there, no? So A, B, here C, D. So continuously you are getting A, B, C, D. Then here we have E, F also. So this is the answer for LHS. Now to find RHS, first you need K union L. So K union L. So K and L, find the union. So A, B, here you have C, D, right? A, B, C, D, then you have E, F, G here. So E, F, G, everything is there, right? This is K union L. Then you find K union M also. K union M, because there are two brackets, find both separately. K union L first, then K union M you find out, then you find the intersection of both, right? So now K union M, K is here, M is here, right? Okay, listen. K and M. Take the union. So here itself A, B, C, D, E, F, H, right? So what are the elements? A, B, C, D, E, F and H. Now you take the intersection here. So K union L intersection K union M. K union L intersection K union M. The elements which are common for these two. Common for these two. See what are common? A, B, C, D, E, F common, right? A, B, C, D, E, F. Then G is here, H is here. They are not common. Take it as 2. 1 and 2, they are same, right? You are supposed to get they are same. Yes, they are same only. So you can say from 1 and 2. From 1 and 2. K union L intersection M equal to K union L intersection K union M. Okay, same way you can prove the first one also. Instead of A, B, C, use the sets what? K, L and M. Okay, now let's go for the next question. See, here verify, they given this. So only that you have to verify. What's the name of this property? One union, one intersection, right? A union B intersection C. A union B intersection A union C. What we did now, similar one, right? But only thing, it is not given in roster form, given in set builder form. So just I'm going to explain to you how to write in roster form, then I'm going to leave it to you. Okay. So say what is A here? Set of all x such that x belongs to z. Z means what? Integer. What are integers? 0, 1, 2, 3, etc. Left side -1, -2, -3, etc. This is set of integers. Okay. Whole number means 0, 1, 2, 3. Natural number 1, 2, 3, 4, etc. Right? Then real number it is a union of rational and irrational. Last class we studied, right? Okay, A equal to set of all integers. See, from where? -2 to 4. But -2 is not included because less than only. If less than or equal to -2 you have to take. So don't take -2 from -1 onwards. -1, 0, 1, 2, 4 is included, right? So take up to 4. So these are the elements you have to take. So A equal to -1, 0, 1, 2, 3, 4. Then you see what is B? B equal to set of all x such that x belongs to W. It's a whole number. Whole number means starting with what? 0, 0, 1, 2, 3, etc. Less than or equal to 5. Less than or equal to 5. So 5 also included. So 0, 1, 2, 3, 4, 5. And C equal to, it is given in roster form, -4, -1, 0, 2, 3, 4. So what they asked to prove, to verify, what they asked to verify here, A union B intersection C equal to A union B intersection A union C. Very easily you can do that. First you find the term inside the bracket. What is that? B intersection C you find out. Then A union B intersection C. That answer you take it as 1. Then to find RHS, first you find A union B. Then you find A union C. Then take the intersection of that 2. That answer you take it as 2. Both 1 and 2 you can see both are same. So you can say from 1 and 2 write the conclusion. You write the statement and you say is verified. Okay. Look at the next question. Similar question, but minus is there, so we'll do this. So A, B, C, everything given clearly. So to find LHS, what's the name of this property? A minus B intersection C. De Morgan's law for set difference, right? A minus B intersection C is A minus B union. The intersection become union. Outside minus is there, right? You can remember like that. A minus B union A minus C. So first you find the term inside the bracket. That is B intersection C. You find out B intersection C elements common for B and C. B and C. See what is common? A is common. C is not there. D is common. G is common, right? I is not there. So this is B intersection C. Next we want A difference B intersection C. What's the meaning? In A. It is in A but not here. Not in B intersection C. In A but not here. Can you say the elements? B you can take. In A but not here. So B. C you can take. It is there but not here. E you can take. G you can't take because it is in both, right? H you can take. It is in A but not here. So this is A minus B intersection C, answer for the LHS. Now we want to find RHS. To find RHS, there are two terms you have to find first, right? There are two brackets, so find them. First you find what? A minus B. So A minus B, A difference B. In A but not in B. In A but not here. So in A, so B you can take because B is in A but not in B. C you can't take. E you can take. In A but not in B, right? E. G you can't take. H you can take. Elements in A but not in B. Next you find A minus C. In A but not in C. Go through. In A but not in C. In A, B, C, right? So you can write B, C, E you cannot take, G you can't take, H you can't take, right? Only these two, B and C. Now you find the union of these two, right? So A minus B, union A minus C. So find the union. Union means you write everything, right? So B, C, E, H. B, C, E, H. So this is the answer for RHS. See 1 and 2, both are same only, no? So you can say from 1 and 2. So from 1 and 2, what can you say? A minus B intersection C equal to A minus B union A minus C is verified. So hope you understood this. Now see the next question, very simple question. Now some Venn diagram question, just we are going to draw some lines, okay? So now before doing this Venn diagram sum, please listen here. So whenever we draw Venn diagram, sometimes they give 2 sets, sometimes they give 3 sets. If they give two sets, this is a basic thing you have to do. If there is only one set, universal set, then one circle, right? This is the common format for any question in Venn diagram, if there is only one set. If there are two sets, if they are overlapping, if they are in disjoint, they'll inform. In the question they mention, okay? If the sets are disjoint means nothing is common, you draw like that. Otherwise, in common, we draw overlapping sets. So this is how you have to draw. Whenever they talk about two sets, you draw one universal set, draw one rectangle, outside you name it U, then two overlapping sets, two ovals, two circles. You take one as A, another one as B. Okay, so here you can, for this you can use some bangles or some pro circle. Okay, don't use composite, it'll take a lot of time, right? So just you make a ring, keep a ring so you can draw very quickly, right? So you can save time. Also equal measurements. So because a lot of circles you have to draw, okay? So the time saving is important, and shading also don't waste much time, okay? Draw some lines with some gap. It should be neat, correct, at the same time you have to do fast, okay? This is for two set. For three set, how the diagram, it should be like this. So outside one universal set, three overlapping sets, name them as A, B, C. This is common generally. Then whatever they ask, you can just shade it, okay? Now let's go for the sum. Look at this question. Verify, can you name this property? A union B intersection C, distributive, good. Distributive property. Union is distributive over intersection. A union B intersection C is A union B intersection A union C. So for this one, verify using Venn diagram. Don't go for any other method. If you take some sets of your own and do, it will be verified, but you won't get marked, right? Because here they specified using Venn diagram. So three sets, so you know this is how it. For this type questions, totally you need 5 diagrams. For LHS 2 diagrams, for RHS 3 diagrams. Okay, for LHS 2 diagram, for RHS 3 diagram, I'm going to teach some easy method and all so that you cannot make mistake. So listen very carefully, okay. So first, already you know it is true, right? No one will say it is false. If you say false, you won't get mark because it is true, because distributive property satisfies. You cannot prove it is, then you will get some degree, right? Okay, now let us see. In the first diagram, for LHS I said 2, right? In the first one, you shade B intersection C. In the first one, we are going to shade B intersection C. Whatever you shade, that you mentioned there. Don't simply shade something. The teacher should know, right? Well, they go, okay, he shaded this portion, right? So first one, you have to shade B intersection C. Second one, the full left side. What is that? A union B intersection C. Okay, so this is the answer for LHS, so you have to take it as 1. So just I'm giving some skeleton, okay, some common rule how to do. Then for RHS, first you need what? A union B. So in the next diagram, you shade A union B. Then in the next one, A union C. A union C. And the last one, the whole thing, A union B intersection, A union B intersection A union C, and that you take it as that's the answer for RHS, right? So now conclusion very important from 1 and 2. A union B intersection C equal to A union B intersection A union C is verified. This is the general format of questions of this type. Even De Morgan's law, distributive property or associative property, this is how you have to do. Okay, now please listen here. Now just we are going to shade it. Listen. First B intersection C, common for B and C. B and C, common portion you shade. B and C common. Now next one, with this you have to attach A also, because A union this one. A union B intersection. B intersection C, got it. With this, you take A also. A also means these three also to be included, right? These three also to be included. So what portion you get, you know? Hope you understood this. Okay, this is the portion you are getting. And one hint I am going to give you now. This is the answer for what? LHS. Answer for RHS also should be the same, right? So same answer you should get here in the last diagram. Now itself you can shade that also, right? This is only for you, right? So that you can save time. But this is not the actual way to do, right? But we want mark also, right? Now listen. A union B, you know that very easily. A union B, A, B fully, right? A union B. But using pencil scale, you draw neatly. This is A union B. Next we want A union C. A union C. So A and C fully shade. Now actually what you do now, after drawing these two, you have to take the intersection. For these two you take intersection. You see what is common in both. You see what is common in both. This A fully, it is common in both, no? So we shaded A fully. Then the remaining, this portion is not here, so you cannot take that. Then this portion is in both, so you can take that one, right? And this portion is here, but it is not here, so you cannot take that. That is how the actual method, okay? But I taught a easy method. To find LHS, after finding LHS, same thing should be shaded to the right side's answer. But check it, it will be correct only, okay? So then finally write the conclusion. Now let's go for one more question of the same type. A intersection B. Now we got clear idea, right? What to do. Tell me for LHS 2 diagrams, RHS 3 diagrams. LHS first, what do you need? B union C. B union C. Then A intersection B union C. That answer you take it as 1. LHS. For the RHS first, what do you need? A intersection B. Then we want A intersection C. Then the union of that two, right? A intersection B union A intersection C, and that is the answer for RHS. So finally conclusion, what do you say? From 1 and 2. A intersection B union C equal to A intersection B union A intersection C is verified. So 1 and 2, that LHS RHS must be same, right? Now listen. So first what you need? B union C. B union C means B, C fully, right? B union C. Okay, this portion. B union C. Now A intersection B union C. Common for A. A means, you know, this full A. And B intersection, what is shaded? Common for what you shaded and A. So then this portion will come, right? What you shaded is the whole thing, but in A also, it is common to A, and that's so only this portion will come. So in the answer also, only that portion. See the portion which one? In A, that 3 part. Then all these things will be true, right? Now A intersection B, common for A and B. Then A intersection C, A and C. If you take the union of these two, definitely you will get this. So shade all this for union. That is not intersection. Intersection means common, right? So you have to shade this portion, also shade this portion, so you'll get the full portion. Okay, to save time, just I taught in that way. You can do the direct method also. Okay, hope you understood. Now we go through the next question. Listen. Verify A minus B intersection C is A minus B union A minus C. So already I have drawn the diagram, just I'm going to share it. But you have to practice a lot of questions. Okay, see that you are finishing these type of questions in at least 7 minutes. These are all 5-mark questions. Okay, so use some pro circle, draw, marking everything important. Okay, shade, and the important steps what I said, equation, taking the answer as 1, 2, then conclusion 1 and 2. Some students, they won't mark 1, 2, but they will write from 1 and 2. Where the teacher will find 1 and 2, right? You have to be very careful in this. So here first diagram, B intersection C. Second diagram, A minus B intersection C. That is the answer for LHS. For the right side, A minus B, A minus C. A minus B, A minus C. Then the last diagram, the union of that two, A minus B union A minus C. That is our second one RHS answer. Then you say from 1 and 2. A minus B intersection C equal to A minus B union A minus C is verified. Okay, now just we shade the portions. First one, B intersection C. You know the portion B intersection C, common for B and C, right? Now the next one is in A, but not in B intersection. In A means 1, 2, 3, 4. That is A. In A, but not in B, what we shaded. So this portion should not come, right? All other A portion you can write shade. So A difference B intersection C. Okay, hope you understood this. But same answer you have to get in the answer also, right? So B intersection C, got it? A minus in A but not here. So don't take this portion, remaining A. So these portions will come. So when you shade carefully, you should not go to the next portion. Okay, so this portion. So from 1 and 2. Now only I want A minus B. What is the meaning of A minus B? In A but not in B. In A but not in B. Next, what do you need? A minus C. In A but not in C. In A but not in C. Okay, in A but not in C. If you take the union of these two, you will get this one. Okay, then finally the conclusion from 1 and 2. Look another one. Just I'm going to tell you, you can shade it. Okay, A minus B union C. So in the first one, B union C. Second one, A minus B union C, right? This is 1. So B union C means, you know, B union C, B, C fully, right? This is B union C. Next, what you need? A minus B union C, meaning in A, but not in B union C. In A means all these 4, right? In A, but not in B union C, not shaded here. So, these 3 you cannot take, right? Only this portion will come. Only this portion. So, same thing is your answer also, right? You can shade this also. Then other 2 you can do very easily. So A difference B, A minus B, A minus C. Here A minus B, here A minus C. Then finally the intersection A minus B intersection A minus C, and that you take it as 2. Then conclusion from 1 and 2. So hope you understood. I want you to complete it. Okay, just I'm going to give another 1 or 2 Venn diagram, and with that we stop today. Look here. Verify A intersection B the whole dash is A dash union B dash. This is De Morgan's law, right? For 2 sets or set complementation. So sometimes they won't give this statement. They will give as state and prove what? De Morgan's law for complementation using Venn diagram. Then both the De Morgan's law you have to prove. Here only 2 sets. So Venn diagrams will be like this. In the first one, you shade A intersection B. Second one, A intersection B the whole dash. That is the answer for LHS. Method everything same like previous one. Next you need A dash. Then you need B dash. Then you need the union of that 2. A dash union B dash. That is the answer for RHS. Now finally you say from 1 and 2. A intersection B the whole dash equal to A dash union B dash is verified. So A dash means outside A, right? Outside A, but in the universal set. Okay, listen here. First, what do you need? A intersection B. This is A intersection B. Next, A intersection B, the whole dash. Leave that portion, shade the entire portion. Okay, all the remaining portions you shade, right? Except that A intersection B, right? Only that A intersection B portion you leave it. You can shade all the remaining portion. So this is A intersection B the whole dash. Next one is A dash. You know, leave A, shade all the remaining portion, right? Leave A. So that is what? A dash. Leave A, all other portion you shade. Next, what do you need? B dash. What is B dash? Leave B. shade all the remaining portion, right? Leave B and shade all the remaining portion. But you can shade neatly, okay? Okay, this is B dash. Now take the union of these two, but by seeing this you can write it, okay? That's the easy method. Or you take the union, definitely you'll get that only, but you have to think properly and do that, okay? So leave this portion, shade all the remaining portion, right? So that is what you get. Leave this portion and shade all the remaining portions. So this Venn diagram, very simple thing. So draw and practice. You must use pencil scale only. Don't use pen for the diagrams. In the diagram, any diagram, even in mensuration or geometry, whatever it is, whenever you draw diagram, you must use pencil and scale. Using pencil, you shade it. Don't use some sketch or some colors and don't use it. Pencil, just draw a line with some gap neatly. Okay. Some students will be just painting. Okay. Don't do all those things. Just draw lines. That's enough. But see that you are not spoiling the page. Okay. So that's all. So like this sum I'm giving it to you. You can do this sum of your own, right? So what they asked here, A union B the whole dash. So first A union B, then A union B the whole dash. A union B means, you know, A, B fully, right? A union B. This is A union B. A union B the whole dash means leave this. Leave this portion, shade only the remaining portion, okay? That is A union B the whole dash. And that is the answer for what? LHS. And take that one as equation number 1. You know the same portion will come for this also, right? Same thing you shade here. And here what are the other things you need? A dash, B dash, and here it is A dash intersection, B dash. 1 and 2 will be same. Then you say from 1 and 2, satisfied everything. Hope you understood. Practice well. So today most of the question I taught from Venn diagram and some other very important things we studied. Set builder form to convert into roster form and all. Practice will continue the next class.